Hi everyone, I am Bihan Chakraborty and today I'll be discussing problem number 23 from LeetCode, that is merge k-sorted lists. Now this is February 22's day 5's challenge, I believe. Yeah, and yesterday I wasn't home so I couldn't record the video. So here we are today. So let's dive into the problem. So here we have been given k linked lists and all of them are sorted in ascending order. So here's the example. So we have been given it's not a list of lists. We have been given a list of the starting nodes of all the linked lists. Okay, so see this one. We have an array of list nodes. So this is the head of all linked lists. Okay, so each linked list is like this. It is 1 4 5 sorted, 1 3 4 and 2 6. These all are sorted, and what we have to do is combine all of them into a single linked list that is also sorted. So once we sort this 3 linked list, what do we get? We get this one, 1 then 2 then 3 4 then this 4 then 5 and then 6. So this is our final linked list and we have to return the head pointer of this linked list. Okay, let's move into the approach. So there are multiple approaches for this problem and I'll be discussing the one using heaps. Okay, so I'm using priority queue here, mean priority queue. So it will always return the minimum element inside the priority queue. Okay, so the approach is, we will start, let me open my editor first. Okay, yeah, so okay, so we will start from the head and we will push these 3 elements into the priority queue. Okay, so initially what do we have? We have 1, then we have 1, then we have 2 inside the priority queue. Now until the priority queue is empty, we will pop an element, the smallest element. So what element do we get? 1. Okay, so now we will move this pointer 1 ahead of it. So what does 1 point to? 4. So we will make this pointer, suppose p was pointing to 1, then we write p equals to p dot next. So now p becomes 4 and we push the 1 into a new linked list. Okay, so let me draw it properly into the inside the editor. Yeah, suppose I have 1 here, 1 here, no, 1 4 5, initially 1 4 5, then 1 3 4 and 2 6, 1 3 4 and 2 6. This is how the linked list looks like. So initially we will create a dummy pointer, let that be -1. Okay, now we will take the first element from the priority queue, that was 1 1 2. So we take this one, suppose the first one, we take it and make the dummy point to 1. Okay, and now we move this pointer and 1 ahead of it, so it points to 4 now. So we will push the 4 into the priority queue. Now we push 4 and 1 is out. So what is the minimum element here? 1 again. So we will again pop the minimum element and make the previous one, this one, point to the new one. Okay, now one thing to observe, this one is not a new node. We are not copying the value, but instead we are directly using the node, because this priority queue is not of type integer, but it holds the node itself, list node. Okay, so this one is actually pointing to this 3 now. So my current linked list actually looks kind of like this. Okay, we could copy the value, that would be simpler, but we're doing it like this. Okay, so we have 1 1 1 3 4. Now we are disconnecting each next from here and then putting something else here. So let me erase it. Now we will again, what do we have? 1 1 3 4. Now we take the minimum element, that is 2, and we replace that 1 to 3's link with 1 to 2 link. Okay, so now what is the linked list now? Actually this points to 6 here, but we break it. We again take the minimum element, that is, oh sorry, I forgot to insert the elements again. So 1 was there, 1 was there, 2 was there, then we took 1, so 4 went inside, then we took again 1, so 3 would be there, and then we took 2, so 6 would be there. Okay, so this is how it looks like. So 2 is done. Now we get the minimum element 3. We put 3 here. 2 was pointing to 6 here because of the original linked list, and we override that with 2 pointing to 3. Now 3 is pointing to 4 again from to the original list, but we will replace that. We take the minimum element now, this 4, so another 4 will be there, so we take any one of the 4. So I am taking this 4, this one was the first one, this 4, so I'm taking the 4 and overwriting it. Now this is done. Now this 4 was pointing to 5, so we put the 5 inside the priority queue. Now take the minimum element, that is 4, we take 4 and overwrite that again. So this is currently looks like this 4 is now pointing to 5. Okay, so sorry about the bad line. Yeah, so it's pointing to 5. Now we don't want that, and now once this is done, this 4 should go to next, and this is null, so we won't push null into the priority queue. So this is done, this part is completely done. Now we get the minimum element, that is 5, and 4 will point to 5. Now 5 also points to null, so we won't put the null inside the queue. And lastly, we have only one element present in the queue, that is 6, so we will write 6 and make it point like this, and 6 also points to null. So that's it, our priority queue is empty now. So we go out of the loop and return this elements next, because this was the dummy node, this was the start node that we create, and we just point to its next because this is the dummy node, we don't want this one, it was just for starting the linked list. Now once this is done, we will return like head dot next, that is the answer, because head dot next is this one, and this is from where the final linked list starts. Okay, so this is our whole linked list, it moves like this. So 1 1 2 3 4 4 6 5 6. Yeah, so what is the time complexity? The time complexity is n log k. Now why log k? N is for traversing the whole like all the linked list, because there are a total of n elements here. Okay, so these 3 plus these 3 plus these 2 equals to n. So we are traversing each element only once, so n into log k. What is log k? Log k is the time taken to insert and like pop from the priority queue. Okay, so push and pop operations and also the peak operation, they take log k time. Now why log k and not log something else? That is because if you check at a time, we have only k elements in the priority queue. Now I have written it like this, so it looks like there are n elements, but if you check, initially we had 1 1 2, right? Now whenever I'm popping 1, the size decrements by 1, then we put 4 here, right? So this becomes 415. Now again we take this one, we remove this one and put 3 here. Similarly we take 2 from here and put 6 here. So every time we take one element, the size becomes k minus 1, and again we push 1, so it becomes k. So the maximum size of the priority queue is always k. So that is why it takes log k time for each operation in the priority queue. So the time complexity is log n log k, and the space complexity, that is k. Why k? Because we are storing k elements in the priority queue. Okay, and actually sorry, the space complexity would be maximum of n or k. Okay, because we are creating a new linked list, so there are n elements there. So that is one, my answer linked list, that is of n size, and my priority queue here, that is of k size. Now we will like the space complexity would be max of n and k, so whichever is greater is my space complexity here. So I hope this is clear. If it's not clear, comment down below, I'll clear the doubts. So now let's check the code. So initially we will check if the list is null or we don't have any list inside, then we return null simply, that is the base condition. Then we declare a priority queue where like this is the comparator operation that depends on your language you're using, but this is basically the implementation of minimum priority queue. So it always returns the minimum element inside the queue. Okay, so now we are creating a dummy element like I said. So this is a dummy element, it doesn't even contain an element here, so you can like put anything, -1 suppose, so because we won't be using it ever. Okay, so now p initially points to answer. Now p is the pointer that will traverse the whole linked list. Okay, so it will like store the elements of the queue and it will connect everything. So we need to move forward, and this is the initial position, we are storing the initial position in answer. So we traverse in the link all the lists and insert the first node of the list in the queue. Okay, because this node is what, this node is the head node, and we have a list of head nodes, so we are inserting all the head nodes in the queue if it is not null, because if it is null we will just ignore that, we don't need to merge null, right? So this operation is done. Now inside the queue we have the head elements, we have 1 1 2. So now until the queue is empty, we are taking out the smallest element inside the queue. So initially it is 1, so we take 1 and make p dot next point to 1. So what was p? P was -1, a dummy element. Now this dummy points to 1. Okay, and this one is this. Okay, this one. So it also points to 4 5, but we will override that in later iterations. So this is done. P moves to p's next. Now p's next is what? P's next is uh, p's next is 1. Sorry, p was initially -1, so p's next is 1. Now we move to 1. Now if p's next is not null, we add p's next in the queue. Now what is p's next now? It was here before. Let me zoom again. Yeah, it was here at -1, then it moves to p dot next. Here it moves to 1. Now we check if its next element is not null, then we add it into the queue. So its next element is 4, so it's not null, so we move, like we put 4 into the priority queue. Then similarly what we have in the priority queue is 1 2 and 4. Now inside 1 2 and 4, what is the smallest? 1. So we take the 1 out, then we connect p with 1. Okay, because p was 4 then, sorry, p was 1 then, my bad, p was 1. We put p's next into queue, that was 4, and here we are again. So we connect this one with the previous one. Now once this is done, we move to this one and put its next, that is 3, into the queue. So similarly the whole thing happens, and until all the elements reach the last, and then the queue empties because we don't push null inside. So this is the problem, and answers was storing this -1, so we simply return its next, that is the first pointer of the final linked list. So let me run it and show it to you. Yeah, so it's working as you can see. So if you have any queries or doubts, please comment down below. I'll answer all of them, and if you have liked my video and my explanations, please like and subscribe. And I'm creating a whole playlist for the February 22 challenge of LeetCode. So yeah, I missed this one, so I'm uploading 2 videos today, day 5 and day 6. So if you want to follow all the videos, please subscribe so you'll get the notifications up to date. And yeah, see you in the next video.